Me. Yeah. All right. All right, so now we do the LED talk. All mixed up together. So I'll first turn on the LEDs. Let's see. There we go. Yay, LEDs. Actually, I have the remote there, maybe. Yeah. Sorry. Oh, of course. Yeah. If I'm here, I deserve what I get. So at this point, yes, absolutely. Let's see if I can get the infrared reader here. Oh, it got unplugged. I'm having a small wardrobe malfunction, but it's not going to be on national news, so it's okay. Well, this infrared, we don't really care about that. It didn't travel so well. Some pins got taken out. Let's see if, well, I'll just fix it here. It doesn't matter. Anyway, so the first version was just LEDs that were one color. But at least I got a power system working for it, and I started using already lithium batteries. So I went into power systems. That's the remote that came with it. So you could just change the color. And that worked pretty well. Then you can see on the pants, I had NeoPixel strips. Sorry, I guess you can't see. They're right here, sorry. Same ones I have on my arms, actually. So that made it a bit more interesting. The top of the shirt was still the LEDs that wouldn't change color. So I found out, that's a longer talk even, but doing infrared and NeoPixels is hard because NeoPixels are driven using interrupt bit banging in most cases, and the infrared is also listening on the pin all the time. And they're both trying to do interrupts at the same time, and one is preventing the other one from working properly. So either you have the NeoPixels working right, or you have the infrared working right, but not both. The solution to that is to do DMA for NeoPixels, which you can do on some platforms, thereby reclaiming your interrupts for the infrared. So that's an example of multiple platforms I went through to make it work. I have yet another talk, which I'm not going to give here, that explains the differences. There's the links in the slides that you can find for that for more details. So that shirt worked pretty well, except, well, can you always do better? The answer is yes. Second thing is those strips were actually glued on my shirt, which made the shirt hard to wash. I understand that I'm French, I can use cologne, but it only goes so far. So after Burning Man, if you don't know about Burning Man, it puts crap over everything you have, and you hate your life cleaning it afterwards. So I thought, well, I have to do something else. So the something else is this, and these guys, which can be taken off so I can actually wash the shirt. And then, why have just lines when you can have a matrix? Because more pixels is more better. So I have about 1,600 pixels now for the matrices and the lines. And I had to use fast LED because I needed to do interrupt driving, which I couldn't do with the Adafruit driver, which I wrote and was dumb. It did bit banging. So someone already wrote the fast LED driver that worked fine, but it didn't have NeoMatrix support, so I wrote NeoMatrix for fast LED. So that's where it is. So if you want to do any of these guys here, you definitely want to use fast LED NeoMatrix. So there we go. That's actually pretty much the guy you're seeing right there. Actually, this one, you probably don't notice, but those are 8 times 32. So they're like 4 slices put together. But ultimately, you use just a mapping function, which is easy to select. So now I can do the NeoPixel shirt, which is what I have right here. So for price, how much do those cost? This is 8 times 32 times 3. So each 8 times 32 costs about $30. So about $100 for the whole thing, except I have, by the way, the same one in the back, so you multiply that by 2. How much power does it use? Well, actually, it's 60 amps if you put it full power. Yes, this is where it came down to the, when you have enough power, any wire becomes a fuse, and that's true, actually. So people ask, so I have questions there on what says, yeah, how hot does it get? Actually, like this is not even close to being full power. Yeah, I should actually maybe fix that thing so I can show you how bright. It gets stupidly bright, and it's limited only by, right now, the 10 amp power converter I have. Okay, I'll just save the time for now. Anyway, so it's only using about 2 amps currently at this level of brightness, also because all the LEDs are not on. It needs to be all white, full power, which it is not. So the 60 amp is the worst case scenario. Really, I'm using 2 or 3 amps more or less. Those are NeoPixels or WS2812s. They're all a chain, so if you lose one time I put the wrong voltage on them, then I blew one and everything died behind it. So you have to replace the pixel, which is what I did right here. That's the back of this, which comes off, but it's all kind of glued together now, so it doesn't come out. But basically, you have to inject power in multiple places because once you use a lot more power, the power that you inject here doesn't make it all the way to the end pixel, so they have different colors, or the last ones don't even light up properly. So this one has 9 power injection points to send the right amount of power. That's because the trace is not big enough, right? If it had a big enough trace, the amps would go through, but they don't. So we talk about being hungry, power. So right now I can at least show you how stupid big those batteries are. I can't show you how heavy they are, but that's what they look like. One for each side. That's actually 160 watt hours, which is more than what you can get on any laptop and just what's allowed on an airline, but barely. And I still had a good discussion with the Auckland security people when I came here. They were measuring it and doing math. I could see them adding up the volts and the amps to make sure it was okay, or the amp hours, I should say. So the good thing is it's 16 volts. It can deliver 200 amps, which is plenty. That would be 500 amps at 5 volts. So if you want to overkill it, you overkill it properly. Of course, if I did that, it would probably not last very long. But I don't need it. It's the short version. I have a 10 amp voltage converter, which is more than plenty. And then I have a second one. I didn't bring it, but I have little glasses that are 200 volts and change that need to be up converted again. All right, so power system that gives you a kind of picture, so I don't have to take out everything. Those are the 2 batteries. Then here I have a fancy voltage measurement system that measures how much current went through them, so it's kind of a battery gauge. It tells me how much I have left. Voltage is not a very good way to measure what's left in a LiPo. It gives you an idea, but it's only approximate. Then I have amps at 16 volts. I think in red, amps at 5 volts in blue. That's the power converter here. That's the up power converter that brings me back to 200 volts AC. And that's just a little ESP8266 in the corner. That's really the only chip that does any work here. All right, there's a zoom on that. So that's the shirt that you're seeing with multiple things. That's what it looks like in its natural habitat. All right. So top questions, I must have this, whether you buy it. Of course, the answer is I didn't. Can I have one? And the answer is no. You should sell this. No, I won't, because then you'll have one too. Then how much does it cost? Several months of software and hardware work, about $400 in material. Is it hot? And that was your question. Actually, it's not, because it's only a few amps. And if you have heat, it means that you're losing power and doing useless things. And those LEDs are actually pretty efficient. But more seriously, can you have one? The answer is, yeah, if you make it. I have all the code online. I have the blog that shows you how to make it. It's just that it takes a while to make, so you should earn it, like I did. And you can make your own. So are you done? Well, almost. So this is nice and all, but you probably paid attention to the fact that the resolution on these guys is much, much, much better, or at least on this one. This one is 6464, so it's 4096 LEDs. So am I getting ahead? Oh yeah, that's the first thing. I want to add animated GIFs, which is what you're seeing on this one. So this is the resolution I have here. You can see that really it's not a lot of pixels, right? You can tell that there's Sonic running better than nothing, but really more pixels would be better. So mission accomplished, not quite yet. So I had a friend who gave me those strips, and for a project that he had, and then when he was done with it, he gave me his 4096 pixels and change. And with the big box, I was like, well, I should do something with them. So I did, because I'm an idiot. It took me about over a week to let them all out, glue them, put the right spacing, solder all the wires. You can see the very thick gauge wire here that can pass 100 amps easily if necessary. The power supplies, which I didn't bring here, are 80 amps each, so it's 160 amps total. Sadly, 5 volts means more amps. And that's not even full power. That's just to make sure that the wires don't melt when I did the first half. And that's the full size. You don't really have scale, but it's about yay tall to do the same amount of pixels than you have here. So this was great for Burning Man display. That shows you kind of how big it was, which is actually not big for Burning Man because everything is huge and lit at Burning Man. But it was still fun, and it survived a week of Playa dust somehow. Yeah, I know it looked bad. It still worked. And I was not the only one to have nice shirts at Burning Man, so there's some random pictures of other people with NeoPixels of various kinds. That one was quite cool, I thought, actually. But yes, can I basically is it the end? And the answer is no. The answer is now to use these guys. They're slightly flexible, not a lot. They're panels that are daisy-chained. They use a completely different way of addressing, which is quite a pain in the rear. You need 16 pins, or at least 14. The way they're driven is, again, the row scanning thing, where every 16, I think, on these, there's a scan, and then it pushes the pixels onto the next panel, into the next panel. So it's pretty much not efficient to talk to them. You have to spend a lot of time rescanning. You have to do the PWM yourself to get color blue, like high blue versus low blue, by just flipping the colors very quickly. And as you can see, they're not very bright because all that time that is spent scanning, when you're lighting up row 1, then row 2 is not lit, so you don't actually see it. And what you're seeing is the persistence of vision, but it's only being lit 1/16th of the time. Sorry, 1/16th of the time. So that's why they're not as bright. And by the way, if you think this guy is bright, it's only limited by the power that's on it right now. If it were full brightness, you'd probably be yelling at me, actually. Never mind at night. So that's the panel you're seeing right here. So ideally, so this is not exactly a very nice thing to put on the shirt, but these guys, I'm hopeful that will work in some way. I still have to work on some wiring, but I'm hoping to rotate it and put it here instead and have a nicer resolution system. So that's what I was doing in the last few days. Oh, and that's completely irrelevant stuff that is not for this talk, so you don't get to see it until Thursday. So hopefully I kind of didn't blow the time too much. That's your second chance to get a link to the slides, or your third chance is on Thursday again. Any questions? Question, yes?
Can you make like super flexible?
You can't. Okay, so can you make it super flexible? It's like this guy, right? Quite flexible. I didn't go into details. You can't see it, but this one is actually a WS13, which has 2 data lines. So if you lose an LED, it will skip over and continue. And yeah, the flexibility is not an issue on these too much. The previous version, I found that the data lines, if you did too much of that, eventually it would break the trace in between, and then I lost the rest of it. So every time I went to an event, I brought a soldering iron, which was fun, in my carry-on so that the TSA wouldn't find it, and had to spend significant time fixing it every night, which was annoying. These actually survive better. This panel, it actually flexes some. It's not great, but it's enough for what I'm doing. But it wouldn't be good enough to wrap around your arm. You have to make a custom one with these guys. And by the time you're doing a matrix with lines, you're going to waste a part of your life away. But no pain, no gain, right? All right, other questions? Very good. Well, thank you very much.